was saying, we started with a map, and just to recap a little bit, we did some editing. We pulled in some data from the city, like the parks, I think, and it was well, actually, it was a AutoCAD file, but we converted it. Well, previous to, we didn't see that process, but that vector data was converted to a shape file, which is useful. And we also, let me go ahead and start it. We also did some editing on it, right? And we did some importing. It was kind of, we just kind of glazed over it or whatever. We imported it into a geodatabase. So we actually dealt with 3 file types here. Well, a CAD file, we didn't really deal with it. We just had it converted, and a shape file and a feature class. So they're different names for similar kinds of animals, but they do have different functions and different properties that act a little bit differently as we look at these things. So here we go. Well, yeah, before we go too far. So we just did the parks and we edited them. I think we were done. Did we finish? We got pretty close anyway. Okay, good. So turn on the projector here. So now I kind of want to, we also added a digital elevation model, right? And so we used a raster and we color coded it. I want to do a little bit more with rasters. So, right. So a raster, again, is a cell by cell, just a continuous surface based data set. I don't know what's going on here. Yeah. Well, it's a very special computer. Maybe if I zoom. Yeah, there we go. Yeah. Okay, so I'm kind of done with the parks, and maybe I want to highlight the park layer and go to appearance and turn the transparency back to like 0% transparent, which is completely opaque. So it may say opacity on some apps, and so 0% opaque is 100% transparency, and vice versa, or vice versa. Anyway. There we go, 0% transparency. Now I can't see through it. You can adjust that later. But anyway, maybe a better color. So a right click on this avoids having to go to the symbology panel on the right. And I can just pick a nice color. There, grass green in here. Leaf green is good. So nice and shows up better. Okay, all right. So we're gonna, I like an exercise where we build our own raster. And this kind of shows how the computer kind of stores it. So I think it's useful. So let's start with Notepad. So I'm gonna go to my Windows Start menu and type in Note and find Notepad and start it. Okay. So, and you can refer to the book as far as the different models. There's like quad tree models, there's run length encoding and things, and they're all very interesting and pretty ingenious. This, what I'm going to show is just a straight out, uncompressed, just row by row, column by column raster that we'll just build ourselves. So what it has to start with is some sort of header information. Right, so let's try number of columns, and I'm just going to do 5, just because I don't want to type too much, right? I mean, most rasters are thousands by thousands, right? But I wouldn't want to type that much. That'd be millions of data points. So let's do 5 rows, 5 columns. So NCOLS is code, if you will, for it can read that. It means something if you put it in a certain file format that a GIS can read. So good enough, right? We're gonna also, So what we need to say is how many rows, how many columns, and what's in each row and each column, each cell, okay? But we also need to know where it is, right? And so that's where we can type in X lower left corner and Y lower left corner. So really that's all you need, because we're going to specify the cell size in a minute. So I just typed those two in, but I'm going to put a number by it. And now this is where we talk about coordinate systems, which is in the next chapter, but we can, I'm going to go back to my map real quick. I'm just going to put a pause on that, and we're going to look at the coordinate system for this map. And how can we tell? Well, I mean, if I move my cursor around, I can see there's a status bar at the bottom where it tells me where the cursor is in some sort of coordinate system. What do you see at the bottom of your screen when you move your mouse around? What kinds of numbers are you looking at? Probably a 108 something, right? A W, and somewhere around the 36.7 something N, right? So what do you make of that? Yeah, right. So those are longitude and latitude, just like you said. Okay, and those are in degrees, right? It even puts a little degree symbol there. But we can change that, right? So if I want some linear units, like if I'm going to put a raster down, I'm going to specify how big, how long those things are. I don't want to put it in degrees. I mean, you could, but that's usually for large areas and stuff, small scale maps. So I'm going to right click on my map. What do you call it? DataFrame. And I'm going to go to properties. See where it says coordinate system? It tells you what coordinate system we're using here. So let's pause here for. It's actually a good issue to have. If you sit at a different computer, you'll need to reconfigure your license, right? You'll need to remap to your Gonzo drive. And you'll need to also, when you start ArcGIS, you'll set where your home location is, which isn't a big deal. And you won't have to make a new folder or anything, but so a little bit of work, but then, you know, you have two computers you can sit out the rest of the semester without having to. Oh, really? Okay. Yeah, maybe shut it down and start it back up or whatever. I'll do that later. Anyway. So what I'd like to do is, since we pulled in this Farmington Parks, notice where it says layers. This lists the coordinate systems of the different layers we have. And one of them is we're going to use the UTM zone 13 north. Let's just do that because it's in meters. And so it'd be nice to use meters. That was probably the DEM because as I remember, those elevations were in meters. So the coordinate system probably was using a metric meter. Yeah. So anyway, I'm going to use that one and okay. You might see it redraw, and you might now, just to point out, you might see that these straight vertical lines that we had drawn maybe are tilting a little bit, and that's normal in a UTM type of coordinate system. We'll talk about that a little bit more later and stuff. But okay, so now this in meters, I'm still not seeing the correct units or at least meters in here. So I'm going to pull down this list and change my display units to meters to match the coordinate system. So now when I move my cursor around, yeah, there's the units are in meters now, and they're still in east and north. right? Just like longitude and latitude. So X and Y, if you will. So nice. All right, so I'm just going to put my cursor maybe next to this, the Lions Wilderness Park here, and just look at the numbers. Looks like I'm at 216,000. And so I'm just going to toggle over to my X. Yeah, in fact, I can see the numbers there, so I could just type it in. Yeah. So you don't have to put a comma or anything. So. And I'm not going to go down to the decimal place here. So just gonna. And you'll notice that the Y coordinate's quite a bit bigger. 4 million something, most likely. If you're in Farmington, it's 4 million. And if you measured how far you are north of the equator, yeah, we're about 4 million meters north of the equator. So that's its zero line, if you want to think of that. However, since there's really no beginning to a circle, well, there has to be, right? And UTM, and we'll talk about it later, has multiple beginnings and endings, right? So those are going to be a lot smaller numbers because they get too big, they just start over to another zone, right? We're in zone 13. So we'll, again, talk about it later. So now we put in a coordinate to where the lower left corner of this whole raster starts, right? Is everybody all right with that? Oh, let me change the font. Is that better? All right, so my lower left corner X coordinate, 216,313, but you don't have to pick exactly that. We picked a UTM zone, 13, yep. Does anybody want to see that again, how to change the coordinate system? We kind of zip through that a little bit. So let's do that. So I right click on my map frame, the properties, coordinate systems, and I just chose it out of, and it tells you what layer. If you pick layers, it gives you the coordinate system of the different layers that you have in your map. So if I want to pick one of those, that makes it convenient. I could go browsing through these other ones, but we'll talk about those again.
Map frame, then.
Yeah, so right click on, well, it should say map. We haven't bothered to change the name of the map, so it's map. And so yeah, right click and go to properties, coordinate system, and then under layers, you should see the NAD 1983, North American datum 1983, Universal Transverse Mercator, Zone 13 North. It's fun. Just because I know you wanted to ask. Anyway, we're good? Okay. So the next one is cell size, right? So this determines how big each pixel, if you will, or cell is in the raster. Let's go 100 meters, right? So each pixel is 100 meters on the ground. That's pretty good. So, well, there's only 5, so it's going to be a 500 by 500 meter square. So, yeah, a couple football fields. Well, 5 by 5, roughly. Okay, and then there's a couple of, one more thing for the data, and this is your no data value. No data underscore value. And we can pick anything you want, like usually you pick like a negative number, so negative 99. And so it's usually a number that you wouldn't find in the data, like elevation. So in New Mexico, negative 99. Yeah, there's no place in New Mexico, I don't think, as far as on the surface, that goes negative 99 meters below sea level. So on this, yeah, so I'm pretty safe to use that as transparent. Basically, there would be no value there, and so you just see through it, whatever layers underneath. That's what we're doing here. Okay, nice. And we just got to type in some numbers, right? So I'm just going to use single digits here. So just mashing buttons right now, right? It's always fun. Oops. So, yep. In fact, it's kind of better if it is. Well, I don't know. I mean, you could do whatever you want. It doesn't even matter. Single digit. It doesn't have to be, but you know. I'm going to throw in a negative 99 there just for fun. All right, one more. So I'm going to do 5 columns and 5 rows. Yeah, 25, if I did my math right. There we go. Apologize for any underrepresented numbers. Just kidding. Okay, and that's it. No other line past that. We're going to end the little insertion cursors right there. And here's the tricky part, if that wasn't tricky. Go to File and Save. And I'm going to go to the right place. Now, we got to be really careful, or I would say really deliberate as far as naming it, placing it, and so forth. So I'm going to go ahead and put it in my folder, my chapter 2 folder. I'll name it test raster 01. Now, file type, save as type. I'm going to put it in all files, and that'll give it nothing, right? So I'm going to put a .asc for ASCII, which is what, the American Standardized Character something or other. What is that? What does ASCII? American Standard Code for Information Interchange. Thank you. Glad you asked. Again, some good questions today. Anyway, so before you save it, yeah, it doesn't matter what you name. Well, I mean, sort of does, but because it has to end in a .asc, you are determining the file type right now for it. And so that's why you can't use the .txt. Because if you put a .asc and you leave it as txt, the way Notepad defaults to, then it'll put a .txt after it and it'll break it. Sort of. You could always remove that txt and rename it, but you know. So 3 things: it's in the right place, it has a .asc after it, and it's all fine. Good? Yeah. In your own, the folder with your initials on it, right? Or whatever you named your folder. It doesn't have to be. Yeah, the name of the file isn't as important as its extension and where it is, so you know where it is. We're good? Okay, then. I'm going to go ahead and save it. And I can just leave it open and just pull it off the screen or whatever. So I'm going to go find it in my catalog and add it to my map, for crying out loud. Do all that work and not do that. That'd be weird. So I'm going to right click on it and refresh, and maybe I'll see it in here. There it is, test raster ASC. Let's drag it into the map. I should see it somewhere in here. Oh yeah, yeah, go ahead. There it is. There's my raster. There's my negative 90. Oh, I only put 4. No, I put 5. We're all negatives. Hang on, let's see what's going on. What happened to those? Dun, dun, dun. Yeah, it only put that fourth row and not the fifth. Let me see if I have to put. Yeah, there we go. Remove it. And I'm going to refresh my folder again. Where is it? Test raster. There it goes. So if that happened to you, I think you do have to put a line break right here. So I got my cursor down in this last empty line. So did everybody else's come in with just 4? Oh, did you have an extra line in the at the bottom? That's kind of weird. Here, let me take it back. Take it back, save it. I'm interested now in how that. Remove. Refresh. To reread that folder, and then test raster 1. Oh, look at that. So it doesn't like not having that extra line break in the end. Is there a space after the 2? After your last one? After your last letter number? So weird. All right, well, again, my computer's special, I guess. Oh, yeah, I gotta remove this. And then refresh. Should work, Very good. Okay. Was everybody successful getting their raster into the map? Nope. Okay. Let's pause and so what can we do with a raster like that? Well, I'll answer it. There's lots of applications, and elevation is one of them. But these could be like weather stations with all kinds of data, and you could cover your area with data that you have from soil samples or any kind of data that covers an area. Would lend itself well, perhaps, to raster types of formats. So, good enough.
So really fast though, the deeper the negative the number, the more opaque it is. Or,
oh, that's a good question. Not really.
Or does it just drop through the map?
It just drops through it, right? So I could have picked. Well, how about 1, right? If I pick a number that's probably in the map, well, there's only 1, huh? I'm going to change this -99 to 1. There. Oh, well, no wonder. I think I realized what my problem. I was missing a number. Okay, and so any 1s in there are going to be no data, right? So, and I probably don't need this. That's maybe was my problem. I'm glad you asked. Okay, so I got to remove. I wonder if I have to remove that. Anyway, I'm going to refresh. Check it later. Put it back in. So now I have 2, right? The 1s in there are the blanks, right? Yeah. Good question. So in the appearance of this thing, I'm using a stretch type of symbology. So it's reading the numbers. I have 1 through 9, right? I don't know why I didn't put any zeros. 0 would have been a good no data value also. Anyway, and I'm stretching, I'm using 256 different values of black to white for my 1 through 9, right? And so it just picks a number. It evenly divides those 256 values by the number of values I have, and it just assigns a shade of gray to each value, right? So, but that's, with data like this, maybe it's better as discrete data, right? So each value gets a color. Like you can assign a color, right? So let's see. Yeah, that's nice. It's still stretching. Well, no, it's not. Let's see what it's doing. It's giving a discrete. Oh, I wanted unique values. Can I do that? Yeah, there it is. That's what I was after. Yeah. So, it hasn't calculated unique values for it, and it doesn't by default because rasters can be millions and millions of cells. and it's not going to like look for each individual number, because a lot of times like elevation, you know, few cells would be the same as some other ones, especially if you had like went to tenths of or hundredths or something. So anyway, so yes, I do want to compute that. So now I can change the color of each value if I want. So let's say I like the 8s, but the 7s are kind of an ugly brown. So I'm going to pick a nice bright color or something, right? So now I can adjust that and control the. So unique values are also useful for when you have many cells that are of the same value. All right, cool. So you can also convert between raster and vector data. So let's say, I kind of want to use the DEM for this. So maybe I'll turn this one off, zoom back out. Yeah, that's my DEM, right? So I'm kind of already color coding this thing in ranges, right? So it's taking 1,589 meters up to 1,876. That's you know, wow, that's pretty close to 256. It's 277 different values, right? So there's almost a color value for each pixel, but not quite. There's a little more pixels than that. But what if I did something like, if I just highlight that and change this to classify, right? So if I classify, yeah, we want to histogram. So this way, I'm breaking it into 5 colors, right? And in ranges of elevation. So now, like, okay, so this is useful if I want to look at maybe the black-footed snail or something, and I know what elevations it likes to, you know, exist in, or, you know, that it's comfortable in or whatever. And so you see more of them there. So I might just break down my elevations into those zones that I might find a black-footed snail. An any-footed snail would be interesting, but you thought the black-footed snail actually existed, huh? I'll just make it up. Okay. All right. Yeah. Sorry. So what I want to do is convert this into, this would do well converting it into like 5 different colors of polygons, right? I could actually convert that to vector data, right? So let's see if we can do that. I'm not exactly sure I remember how, but it's probably under imagery and maybe classification tools, probably not. Maybe under analysis, and I'm just going to click on the toolbox, although I might see it in here. Yeah, probably not. Anyway, what I want to do is raster to polygon. How about that? So I found the raster to polygon features, and if I want to know where that is, let's see if I hover over it. No. Oh, question mark. Well, it's kind of what we already explained. That's not where I wanted to go anyway. So I'll close that. Go back. I wanted to know where this was in the toolbox. Sometimes that's useful too. I thought you could just hover over it and know. No. Nope. Huh. I'll have to look where that might be. Anyway, let's fill this out. The input raster, and if I just pull down this list, you could browse for some other data set that's not in your map, or you can just pull down this little list and it'll give you the only 2 raster data sets that are in the map, which the DEM is one. So I'm going to pick the DEM as my input. And my output polygon, so this is the name of it, and it's going in my geodatabase, which is fine. And I'll just use it. Let's call it elif zones. How about that one? Maybe I'll make some more. Simplify polygons. That's fine. Yeah. And what that'll do is, you know, if I look at the pixels here, the cells, it'll just follow. If I don't simplify the polygons, it's not going to draw a line through. It won't smooth it out. It'll be just as stair stepped as the raster, as the cells themselves. That kind of rhymes. So anyway, create multi-part features. Not really. What that means is a multi-part feature would be like Hawaii. Right, Hawaii, each island would be its own polygon, but they're all in the same Hawaii polygon. And so they have multiple polygons in one feature, right? So that's called a multi-part feature. Well, I kind of want each polygon to be its own animal. So I'm gonna leave that. And we don't need to put maximum. And you can click on the information there and it'll tell you what those things are, but that's okay. Oh, environments. So here's where I can make sure the coordinate system matches the current map, right? Which is that zone 13. So I can keep it in the same coordinate system, but if you want it, like you can put it into a different one, which is kind of useful too. It's called reprojecting. There's a tool for that as well, but anyway. All right, so I don't think we have to mess with anything else. Let's just run it and see what it does. So if you follow what the ticker down here, converting the raster to polygons, it's not really more descriptive than that, but and it should automatically add it to the map. So we'll see what we get. Nice. Well, the only problem here is it took every cell and made, okay, well, every cell has its own. Now let's just go to the attribute table here and look what it did. Yours failed. All right, let's take a look at why that might happen. But each one got its own. I mean, I have 480,259 polygons. Let's see how many cells I have. Raster information. Well, I should have millions, so I guess it can a couple of them. I thought the symbology, it would read the symbology because I thought it would do that, but it didn't. So we're going to try it again, a little easier this time. But yeah, let's pause and make sure we're. All right, so because it gave a different polygon for every elevation, and it's not super helpful, I mean, it won't be too much different. In fact, if I symbolize this thing, I don't know, or if I go to appearance and symbology and do like graduated colors, then it comes out almost identical to the, and a whole lot longer to draw. Remember, vector was more intensive on the computer, not the file size, right? And so now it's having a hard time just undrawing this thing. Well, actually, I can't even tell. Let's see that? Hard to tell the difference. Okay, so let me turn it back off. This is the original DEM. So yeah, one's vector and one's raster, and so that's not very helpful. But if I select my DEM and reclassify it, I think that's actually under imagery. I don't know, it might be. Reclassify. Classification tools, maybe? Classify. Let's try that. So train, yeah, maybe not. That's what I don't want to do. Yeah, this is useful for, well, actually, no, I don't want to use that. I don't have to use that. Maximum number of samples per class. No, don't want that. Output, that is not what I want. Let's try. That is what I want to do. But I want to specify what to do with it. I guess I have to make a training sample, but I thought there was an easier, let's just go to tools. There's an easier way to do this. Could be under raster functions. Let's check that one first. Classification. Well, that is going to do it all by itself, and I want to do it. I mean, I don't want to have to train it. Like you could set up a trainer. Maybe that is what I have to do. I didn't want to have to do that. Training samples manager, and then so what do I make a new one? Create new schema. This is dumb. I should be able to just use the symbology. Yeah. Well, I don't know that. Generate from classified raster. Use default schema. Nope, don't want to do that. Don't want to do that. Don't want to do that. Okay, that's not what I want to do. Let's try under analysis and tools, and I'm just going to search for it. So toolboxes, and there should be some spatial analyst tools, maybe. And reclassify, maybe that's the tool I want. So the input raster, I feel like I went that too fast. So if you scroll, okay, so I went to the toolbox, right? Under the analysis ribbon. So I'm backing up here. So analysis ribbon, tools, and then you have favorites. Well, it's not in my favorites. It's in toolboxes, and if I scroll down to spatial analyst tools, that's actually one of the extensions we activated. Does everybody have that, by the way? That's good. And then I go to reclass. There's a reclass drawer in the toolbox or compartment. And then there's the hammer, the reclassify tool in that drawer. Got it? So I click on the reclassify tool. The input raster is my DEM. The field, basically, what numbers am I going to use? Some rasters have more than one column, like in an attribute table, to use, but this one just doesn't. So that's good. And then now it's going to start at the lowest value, which is 1589, and the ending value. So it's kind of doing it itself. You could make it into like nice numbers, like end at let's just end that at 1650 instead, right? And then start this guy at 1650.01. Oops. See what I mean? And then go to, well, I don't know. Yep. Oh yeah, so that's because it's an extension. You might find that you can't use it, right? So what you do, if you're not seeing that, if you can't use the tool, go back to project, go to licensing, and see where it has extensions, and see my spatial analyst is, it says yes here, and if it doesn't say yes there, well, you're out of luck. No, I'm kidding. So we can go to configure your licensing options again. Probably. And it's going to take a minute. How many, which computers are doing that? A couple of them, right? 3 or 4? So okay. So yeah, go to licensing from your project menu or ribbon. Okay. And we're going to keep it at concurrent use, but down here under the options, just make sure you check the boxes. And are the boxes checked? I'm guessing not. Okay. All right. I'm going to pause. I guess I'll resume recording now.
Oh, yeah.
Nice. So that happened a lot faster, huh? Because there are only 5 different zones of elevation. So let's review that real quick because I forgot to start recording. So I just redid, so I used the reclassify tool in the spatial analyst toolbox from there. Yeah, reclassify. And I put the input raster and just set up the values every 50 meters, right? And so these are 50 meter, roughly. Well, in between they are 50 meter, but in the on the ends it's roughly 50 meters. So I'm going to use this one to convert to polygons, and so I should have a lot fewer polygons now because I only have 5 different ones, 5 different values of elevation zones. So let's try that in a minute. Now that that's what reclassifying is. That's something that's nice. And so now I want to make polygons out of this data. And so that was our, so I'm going to go back and change that to, oh yeah, raster 2. I want to search for that. Just hit enter. So raster to polygon again, right? So I found it. This time I'm going to use the raster I just made, which is that guy. This will be elif zones 2. Yeah, I'm just going to name it elif zones 2, I guess. Yeah. Environments. We're going to use the same coordinate system as the map. What else? Simplify polygons. Well, I'll show you what that means, basically. But okay. Question? Sorry. We'll back up. Okay, so that's pretty much it. Coordinate system of the map, reclassifying that 5 class DEM, basically the reclassified DEM, and name it something. Simplified polygons. Run it. Okay, so here is a vector representation of those elevation zones. And I can certainly go to appearance and symbology and unique values. And I should get something. Oh, yeah, what am I? Oh, but what's it based on? ID number? No. How about grid code, right? So now the grid code is actually ends up being, it passes the elevation value to that field. So notice also that it gives different numbers. The reclass, we didn't really pay attention to that, but the reclass gave that elevation zone a 1, a 2, a 3, 4, and a 5 instead of those. I mean, it can't give you 2 numbers, right? So it's just 1 number for that zone or range of elevations. So anyway, that's kind of fun. Just fun for me. Just kidding. Okay, so what we did was vectorize a raster, right? And so now we're going to rasterize a vector. That'll be cool. So when you go home, your mom asks you what'd you do today, you can say, well, we vectorized rasters and rasterized vectors. Okay, have fun. So I'm going to use parks, the Farmington parks. Let's just hide this one for a sec, and the rest of them. And back to the parks here, right? So let it refresh. Maybe I want to, and there's a reason. So I'm trying to come up with a reason why you would want to do this, right? And there is, because mathematically, it is a lot easier a lot of the times to, like, say I wanted to find out which parks were in a certain elevation zone, right? And so I could multiply the parks. I could make a raster out of the parks to have, you know, everywhere there's a park, it's a 1, right? The raster has a value of 1. And everywhere there's not a park has a 0, okay? And then I could just multiply those two together, the elevation zones and the park, and a 0 times anything is 0, right? And a 1 times anything is, well, a number, right? And so then I can get an elevation zone within just the parks. So that's kind of like clipping or intersect. That's called an intersect, actually. So you can do that with vectors also, but mathematically that's much more difficult to find, like, inside something rather than just it's there and it has a value, right? So yeah, anyway, let's just rasterize these parks and say you understand. That's good. But there are reasons, in other words, and to be able to do that. So all right, so we're going to use the tools again. And instead of raster we should use feature to raster, maybe. Yeah, look at that. Feature to raster. So the input feature is going to be our parks. And the field, well, gee, it kind of doesn't matter what field I'm going to use for. In fact, if I hover over this, what does it say? Is it going to say anything? The field used to assign values to the output raster. Maybe the name, but it'd be nice if it was a number, right? So maybe object ID is what I want to do. So I'll leave it as object ID. It'll just be a unique number for each park instead of the name of the park, which is fine because, well, I'll lose that data, but that's okay. And so FMTN parks. So another thing that I saw was kind of confusing with this is once you click in the output raster, you want to change its name, it gives you the whole path. And so if the path is long, it, you know, fills up the whole type in box. And so we're not sure how far back to type. It defaults to the geo database, right? So right after the backslash on the geo database is the name, right? But it's possible to have containers inside the geo database, like feature data sets. Those are like subfolders for the most part. So you got to look through and just find the last backslash basically for the name, okay? So that's confusing, I think, as well. That is. So yeah, let's just do raster parks. 1, because we'll probably do another. And then you get to choose the output cell size, right? So how fine a resolution you're going to use. Right now, 146 meters is, maybe I'll just go 10. That's a lot more fine of a resolution. Environment, coordinate system, same deal, and run it. Let's see what we get. Updating, cracking features. So there we go. It's under the park, so let's change that. So now each park has a different value, I guess. It's actually let's change that to unique values. So those are the different parts, and they all have a different color. And they're raster values now. So if I zoom in on a part, I can see it's stair-stepped rasterization of it. There you go. Oh, and I wanted to point out the here's the reclassification. Let me turn off the parks here. Yeah. Here's an elevation zone if I let it redraw. It didn't simplify those polygons very much. Oh, that's not the polygon. Where's my polygon? Oh, it's up here. So yeah, if you see the difference, see how it, let me put the ones under it. See reclass right there. So how do you compare two that are like just layered on top of each other? You can go to appearance and swipe. The swipe feature is real fun. So you can swipe left or right or up or down. Hello. Let me turn off the imagery. That might make it a little bit. Okay, so I'm kind of just swiping that away from it, and so you can see the polygons and how they smoothed out the stair stepping. Let me zoom in on that a little bit more. See how it just kind of drew across the centers of those polygons, or the pixels or cells. So it's more of an average on the boundaries. So anyway, so that was that checkbox where it says simplify polygons. So you can do that. If you don't, it'll step it right to the edge. So there you go. Okay, all right. So we have a lot of stuff in here that's not going to make a very good map. Yeah, we have all kinds of kind of a playground. Well, parks should have a playground. So. All right, good. Yeah, I was going to draw some roads and then we could rasterize the roads, but I think this was good enough. So I think, yeah, just for good practice purposes.
So you could lose some information if you were to rasterize it this way, correct? So if you were trying to survey a line of someone's area, it would not be accurate.
Right, you would want to keep it as vector data. Right. But if you were, surveyors also take like grid surveys of elevations, and then they would make a raster out of that. So there is a reason why you'd want to rasterize some things, some vector data or whatever. All right, so let me pause the recording. And so yeah, my thought is I want to print the parks and we could have the imagery as the background. So we'll make another Farmington map with imagery in the parks. And I think we don't want the elevation in the way because it's just this blotch in the middle of everything. So we'll leave that out, I guess, for now. Okay. So we'll lay this out, and that'll be the assignment for this chapter. So yeah, there was a good question. If you have an item like a park selected and you run that tool, it'll only run on that selection, right? So like you could just rasterize a single part or maybe two if you want to, and inadvertently if you don't want to. So that was a good experience for some of us. So good job. All right, so we're done for that. And again, the layout, I still have 30 seconds. I can right? So we're going to insert a new layout, right? Maybe because it's Farmington again, we'll do a landscape letter, right? Okay, and then just to go through it, we're going to insert a map frame and the current one, right? So that current one is at whatever scale, and it's not the scale I want necessarily, but give it a margin and just draw it inside your paper. And then you can change the scale, and I think we already know what scale we wanted to use, right? 63,360 is a great scale, 1 inch is a mile. But we may want to activate and pan around, take out some of the stuff and whatnot, and this, that, and the other thing.
You want the world surface marathon?
No, I think because we're going to use the county imagery, we can just leave it like this and just get all the parks where they should be. In fact, you could just, well, yeah, I think this looks pretty good. Maybe we would want to put the boundary on it, but maybe not. I kind of like it like that. We'll label them, right? And go from there. So save the project at this point. Title, north arrow, and we're good. Sound good? So we'll leave it at that.